In today's lesson, we will graph quadratic functions and primarily focus on the three forms, standard, vertex, and intercept. We will go over definitions, look at the three forms, and discuss changing between the three forms. A quadratic function in standard form is y equals ax squared plus bx plus c. When you graph a quadratic function, it is called a parabola. A quadratic function has a vertex, and the vertex is either the lowest or the highest point. We will also call it a maximum or minimum point. A quadratic function, when graphed, also has an axis of symmetry. And the axis of symmetry is the vertical line through the vertex of the parabola. And in our example, we see the axis of symmetry. In standard form, which is y equals ax squared plus bx plus c, we can determine if the parabola opens up or down. If a is positive, it opens up. If a is negative, it opens down. The x-coordinate of the vertex can be found by using the formula negative b divided by 2 times a. Once you find the x-coordinate, to find the y-coordinate, you just take that x value and substitute it back into the equation. You can also get the axis of symmetry by using the formula x equals negative b over 2 times a. Now, if you want to graph, all you have to do is choose two values to the left and two values to the right of the vertex, and then find the corresponding y values to get the ordered pairs so that you can plot the points. Vertex form of an equation. Vertex form we've also seen before. It's y equals a times x minus h quantity squared plus k. When our equation is in vertex form, we can immediately find the vertex, which is the point hk. And again, just like before, if a is positive, the parabola opens up. If a is negative, then it will open down. And the axis of symmetry, when in vertex form, is x equals h. To graph an equation from vertex form, you use the same method when it's in standard form. Plot your vertex, then choose two values to the left and to the right of the vertex and find the corresponding y values to get your ordered pairs. Next, we have intercept form. Intercept form is y equals a times the quantity of x minus p times the quantity of x minus q. The x-intercepts are the p and q. And we find our axis of symmetry by using the formula x equals p plus q divided by 2. And again, if a is positive, it opens up. If a is negative, the graph opens down. Now, let's apply those concepts. In this first example, we have an equation that is in standard form. Our a is 2, and because a is positive, we know that the parabola will open up. Now, how can we find the vertex? To find the vertex, we use the following formula to get the x value first. Negative b divided by 2 times a. B is negative 8. A is 2. We substitute in the formula as we see here, and the x-coordinate of the vertex is 2. Now, how do we find the y-coordinate? We take the value of 2 and substitute it back into this original function for x, and we get that y is equal to negative 2. So our vertex is 2, negative 2. Now, our axis of symmetry is the vertical line x equals 2. To plot our points, we see that here we have the vertex of 2, negative 2. So we choose two x values that are smaller than 2, and then two x values that are larger than 2. And we take the 0, substitute it back into our function, and we get 6. We take the 1, substitute it back into our function for x, and we get 0. We do the same for 3 and 4, and we get the values for y. And now we plot all of these points on our coordinate plane, and we have our parabola. Now, you try one. Pause the video, answer each of the questions, and then restart the video to check your answer. Okay, first question. Does this parabola open up or down? Because A is equal to -1, it opens down. What is the vertex? To find the vertex, we want to do -b over 2a to get the x value. So our x value is -1 over 2 times -1, which is a positive 1/2. So our vertex, the x value is 0.5 or 1/2. To find the y, we're just going to replace the x with 1/2, and that will give us our y, and that gives us 12.25. So our vertex is 1/2, 12.25. Now what about our axis of symmetry? X equals 1/2. And to get our table of values, we just choose 2 points to the left, 2 points to the right of our x value from the vertex, substitute those values in, and to get our y values. So here is our solution along with the graph. In the next example, we see that we have an equation that's in vertex form. Now, the great thing about vertex form is that we don't have to do any calculation to find the vertex. Our vertex is HK. And so in this instance, our H is -3 and our K is 4. So our vertex is -3, 4. Our axis of symmetry is the vertical line, x equals -3. And because A is negative, our parabola opens down. To get our table, we choose two values to the left of the vertex, two values to the right of the vertex, to the right and to the left of the vertex. And then we substitute in to get our points. Now you try this one. Pause the video and then answer each question. Now, here's the answer to the previous problem. Your vertex is 1, -8. And here are points that are plotted, and your axis of symmetry, x equals 1. Now, this equation is in intercept form. Looks a little bit different. So let us do this one. Does it open up or down? Well, we notice that our A is an understood +1, so it opens up. Well, how do we find our vertex? Remember, to find our vertex, we have to do P plus Q divided by 2. So we will do 3 plus -7 divided by 2, and we get -2. That is the x value. So once we find that x value, we take that x value and we substitute it back into the original equation. -2 minus 3 times -2 plus 7. And we get -5 times 5, which is -25. Our axis of symmetry is x equals -2. Next, we will do our table of values using 5 points. Now that we've discussed graphing when we're in each of the forms, let us discuss changing to standard form. If you are in intercept form and you want to go to standard form, all you have to do is use distributive property or box method. So here we've done that, and then we're going to multiply through by -1. And now our equation has gone from intercept form to standard form. If we want to go from vertex to standard form, again, we're using distributive property or box method. We know that x minus 1 quantity squared means x minus 1 times x minus 1. So we multiply that out, and this is the result. Now we multiply by 3, and this is the result. And now we combine our like terms. And so from vertex to standard form, we get y equals 3x squared minus 6x plus 11. Take a moment to view each of the processes again, and please jot down any questions that you may have. Next, we will change an equation that is in standard form to vertex form. So we're going to look at y equals 2x squared minus 4x minus 3, which is in standard form, and we're going to change that to vertex form. So the first thing we want to do is find h. And to find h, we use this formula. So h is equal to -b, which makes +4, over 2 times 2, which gives us 1. So our h will be 1. To find k, we're going to take that value of h and substitute it back into our function. So we're going to take the value of h and substitute it into our function. And when we do, we get that k is equal to -5. So that means our vertex is 1, -5, and we substitute that back into vertex form, along with our value for a from standard form, which is 2. So we're going to take the 3 values and substitute them back into vertex form. And we get y equals 2 times x minus 1 quantity squared minus 5. So we've just gone from standard form to vertex form. Now, your assignment is to write 3 equations, 1 in each form. Write 2 or fewer questions you may have, but if you have more than 2 questions, please feel free to write more than 2. And write 1 equation in standard form that has a vertex of 3, -2.